All right. Number 17. Which of the following is used to draw an octagon if the length of one side is given? We did look at this on that diagram. It would be a 45-degree set square. A 45-degree set square, which is B. Number 18. What would be the first step to divide this line into the ratio of 4, 5, and 3? So we have 4 steps. I'm giving you some time to think it through, like about 30 seconds. What would be the first step?
Sir, I'd say C, sir.
Step off 12 equal divisions and AC. Step off 12 equal division and AC. Mark off 12 equal division and AC. That's the first step. Yeah. The next step would be to mark off 4 points, then 5 points, then 3 points. And then join the last point to B to get that. Yes. All right. Number 19. Yep. Again, we looked at this question also on the in the text. I'm giving it some time to work through it. Given that one of the angles of a rhombus is 120 millimeters, which of the following is the value of one of the internal adjacent angles? All right. This might require some explanation. All right. So let me explain this. So we have one side like this, one side going like that. We have one side here, one side there, one side there, one side there. All right. This is a rhombus, right? This is a rhombus. Here, this angle here is 120. Angle there is 120. This angle is 120. Here is 120. Down here is also 120. 120 also. Because opposite angles are equal. So if here is 120, here is 120, and all 4 angles add up to 360 degrees. So it is 120 plus 120 gives us how much? 240, right? Give us 240. Yeah? When we subtract 240 from 360, how much we have left? So 360 subtract 240 is how much? We're left with 120, right? 120. That left us with 120. We're left with 120. Are we following? So we have 120 plus 120 give us 240. we subtract, and all four angles must add up to 360 degrees because this is a four-sided figure. So we are left with 2, 1, 0. Now, this 120 must be shared between these two angles. It means, therefore, we are to divide this angle into 2 because the angle here is equal to the angle on this side. So if this is 120 divided by 2, we have 60. 60 there and 60 here. All right, 60 and 60. So the, oh yes, we have 60 here. So 60 would be the correct response there. Capish? Capish, guys?
Yes, sir.
All right. All right. All right. So let's move on to this other one. Again, we looked at something like this in the book. All right. What's the angle of P right here? The value of P.
Sir, A,
Remember,
sir, 30.
angle on a straight line measures 180 degrees. So we have, here we have 90 plus 60 is 150. When we subtract 150 from 180, we're left with 30. Yeah? So this angle is 30 degrees. They tried to put this in the form of a triangle to confuse you. Yeah? But don't be fooled by that, okay? All right, good. Let's move on to this one, 21. A quadrilateral with one pair of parallel side is a, again, we looked at this one in the book. Which one is this? This quadrilateral, it has no side or angle equal. So all angles and sides are unequal, except that two sides are parallel. So it's a trapezium. Trapezium, yeah? That's all four sides and angles unequal. What's the answer for 22? Which of the following diagram shows a triangle of equal area between parallel lines? Shows a triangle of equal area between parallel lines. Yep. Which one? All right. Let me pick your brain for a little bit. All right. Any triangle that is formed within the same altitude, once it has the same base and the same altitude or height, the area is always equal. So here is A, base is AB, so from here to there, oops, sorry. So even if we extend this all the way out to there, and we have here going all the way out there and coming back to touch this section right here, once the eye height is the same, they all share the same area. So we have 1, 2, 3, 4 triangles having the same area. So which one of these is correct? Yep. Which one of these is correct? Which of the following diagram shows the triangle of equal area between parallel lines? Has to be A, right?
Yes, sir.
Yeah. What about this one? I would really like if you guys support me, because the excess talking after a while, it's hard to get, it affect my throat. What's the answer for this one? We looked at something like this also in the book. Yeah. The correct response would have been A. Let me confirm. Yeah. Using using orthographic projection for the diagram above, which view which view which view G as the front and the end H will be. Using orthographic projection for the drawing above, which view G as the front and end view as H. So G as the front. So this one. This is the view H. So this view that as A, this view that has the front, G as end. All right. Let's move on to 24. Which of these represents an external tangent? External and internal tangent. This one here, B, external, internal. $25. Which of the following shows the best method of bisecting an angle? That would have been A. Let me see. So here we draw this, then from this point we square an arc, then from that point we square an arc, so it would have been A. Any question there? Any question? All right, number 26. Guys, I would really appreciate if you guys give me some feedback or at least give me the answers, supply me with the answers. as that would minimize the talking. Number 26.
Sir, A, sir, a cycloid.
Yeah, cycloid. 27.
Sir, it's 1 to 2, sir. 1 to 2.
Half, yes. So if we were to split this up into a number of parts like this, so here we'd have 1, 2, 3, 4, 5, 6, 7, 8. And this has 1, 2, 3, 4. So this has half the number of parts as this. So it would be 1 to 2. 1 to 2. This one, 28.
Sir, B.
Yeah, B. 29.
Sir, A, sir, 30.
A, 30. Yes, 30 degrees. 30. A. That's A. A for that one. 31. If the length of a line on a drawing is 25 millimeters and the scale is 1 to 10, then the actual length is, and I multiply this by
Sir,
10 is how much?
there must be D, sir. D.
Yeah, 250 millimeters. Because you reduce it by 10 to get that. So it will be 250 D. 32. The rectilinear accuracy of the figure can be tested by measuring the
So, sir, B.
diagonals. Measuring the diagonals. So if from here to here is the same distance as from here to here, you know that it is the corners are square. So it's the diagonals from here to there, diagonals. Which of the following, this one, is eccentricity if FP equal PQ, if FP ratio to PQ is equal to that, FP, and PQ. This symbol means that what is here is also equal to here. So if here and here equal, which ratio would this be? If the distance from here to here, if distance from P to F is the same distance of P to Q, what does that mean? It is in the ratio of 1 to 1. All right? Ratio of 1 to 1. I don't understand why so few persons on plan card to show up. All right, this question. This comes back from what we're looking at in the book. Which of the following development shows a cylinder which is cut obliquely at both ends. Obliquely at both ends. Remember what oblique mean? Mean that you cut it slant, yeah? Oblique or truncated, yeah? D. Answer here is D. Oblique mean that you cut, the cone is cut like this. You have a cone like this, and you cut off a section, probably like this. Cut off a piece like that. Either that way or this way. So you cut it like this. You cut it like this. So this would be this would be the new shape. You cut it like this and you unfold it. So this is circular. You unfold it, you would get something looking like this. Remember oblique? We looked at the word oblique before. Yeah? Oblique
Yes,
or
sir.
truncated. So it would be this. This one, 35.
Sir, B. Oh, sir, is it B?
French curve? Sure. Yep, French curve. So that would be a French curve. Right. See another question here. This one is also similar to what we looked at before. What's the answer for this one? Yep, 36. Remember this one? We looked at this one also. This is a cylindrical pipe. Yeah? This one is cut at the top at one end. Yeah? So we have the pipe right here. We cut the pipe at one end and they allow it to unfold. We pretty much open it. So once you open this, we'll end up getting a pattern like this. Remember when well, it probably not wasn't able to retain so many things within such short time. But this is what we get from that. All right. So this one, 37. The perpendicular distance between line the perpendicular distance between lines PQ and RS of a trapezium. So a trapezium, remember a trapezium has all four sides and angles unequal. This is basically a trapezium. All right. So the perpendicular distance, which would be this distance here. The perpendicular distance. So the perpendicular distance between line PQ, line PQ, PQ, and RS, of a trapezium PQRS is 35 centimeters. Which of the following line would be parallel? PQ would parallel to RS, PQ and RS. So PQ would be parallel to RS. All right, which one? PQ, R, PQ.
Yes, sir.
Sir,
CTS.
B are my
Just
answer.
reverse it, sir. They just reversed it
Yeah.
because it have RS and
Yeah, B are my
QP.
answer.
B, yeah. Or RS, yeah. All right, yeah. All right. The line mark X on the diagram are symbols which indicate
Sir,
a,
D, sir, the continuation of the objects.
yes, meaning that it continues. You pretty much, yeah, it does show a part of it, yes. Continuation of the object, yes. And this question return again might be in a different form. Let's see what this question says now. What's the answer for this one? Triangle ABC is drawn within a semicircle of diameter 100 millimeter. AB is equal to 80 millimeters. What is the length of BC? So here is 80. You know, for this one would be within, so AB, triangle ABC, that is 80. That is 80. AB is equal to, AB is equal to 80 millimeters. Okay, so it's good to bring a compass with you in the exam. So you would quickly draw a line. You'd quickly draw a line. There might be some maths you can use. Well, you could look at the answers and just guess it still. But to be 100% accurate, you could also work it out. You could also work it out. So I would just bring my compass. It's good to bring a compass with you and a ruler and probably a geometry set would be good. So if here is 100, here is 80, BC is 80. You can pretty much look at the answers that they give you and guess the length of this side, BC. So if here is 80, here is 100, here is 80. What you could do is to work this out, actually, you could open a compass to 50. Open a compass to 50. Using here as center, draw a semicircle. Then open a compass to 80. Open a compass to 80. Square an arc. Using here as center, square an arc right here. Then you measure from here to get the other part for the triangle. So here would have been the distance, the answer. So again, you just draw a line, open a compass quickly to 50, which is half of that. Draw a semicircle, adjust the compass to 80, put it here, square an arc, then measure from here. So here to here would give you the triangle. So you would measure from here to get BC. Yeah, quickly, a couple seconds and you're done. Or you could use the answer that they give you. Or there's a math formula that you could use, which I don't remember, to get that as well. But for drawing, remember, bring a geometry set into that exam and a calculator. So based on what we have here, this seems to be around, I would say about 50, without using anything to measure anything, I would say it's about probably 50 or 60. It's about 60. I would say BC is around 60. But don't take my word for it. Just use an instrument and do it and sketch it. 40. But well, back to 39. Which do you think is the correct response? Which do you think would be the correct response for 39? Yeah? You think 60 will be good or 50?
Sir, 60, sir, 60.
Yeah, I think 60 because if here is 80, 60 would be about 2/3 that would, which would be about like right here, about here. So I would say 60. It could not be 32, it could not be 36 because here is clearly more than half. So it has to be between these two. And from here to here is about 2/3 of this distance. So I would say it's 60. Number 40. Yep. Flex curve is a flex curve. Is a flex curve to measure irregular curves. Or there is no French curve, so you use a flex curve. Flex curve and French curve are used for the same purpose. A flex curve is like a piece of, it's like a ruler that can bend or can curve to draw different shapes. You can bend it up to form different shapes. Flex curve. What about this example? Remember, I showed you something like this before. What would be the angle of this beta?
Sir, it will be 60.
60, yes, 60. 42.
Sir, C.
C is the correct response. 43.
Sir, B.
T squared. Yes. 44.
Sir, D.
Yeah.
C, sir.
Any four-sided figure is referred to as a quadrilateral, quad or four. Triangle has three sides. Polygon, well, a polygon has more 5 or more sides. Number 45. That would be A. That would be A.
So it was kind of tricky, sir, because on the fence between A and D.
Yeah, so for this, yeah, it's a little tricky for real. So you'd first draw the line, then draw a line from there, random length, then divide this line into in that case, 5 equal parts. Then you draw the last point to here, Then use your set square to draw parallel lines across. This one is like a ratio of 2, 1, 1, 2, 2, 4, and 1, 2, 3, 4, 5. So this will be a ratio. This one could not be correct. The line must touch this at that point. So that is out. So A is the only correct response. "46. Again, we looked at this here. We did touch on this. You have two methods of drawing it. Well, more than two methods. Which of the following method of drawing an ellipse involves constructing a rectangle? It's the intersecting lines. For that, we have the ellipse like here, and we have lines going from here and we have lines. We divide this into the same number of equal parts. Remember this? I showed that diagram earlier of this. Then you join these up there. We did this. Yeah, capiche?
Yes, sir.
So this is intersecting lines, right? That is C. 47. Development is the unfolding of a surface. Unfolding of a surface is the development. 48.
Sir, B.
B, yes. And again, this was among those that we looked at earlier on. 49.
Sir, A.
Yeah. A. Yep. This one, 50. This one, it will form an ellipse. An ellipse will be formed. As this point moves around, it will form an ellipse. I didn't spend much time on this one in the book.